sorry, it is.
Oh yeah, no worries. Do you need me to rename it, or are you able to rename it?
I can.
All right, fantastic. Yeah, no worries.
Okay.
All right, Brian.
The first equation, I think it's the equation. This equation is solving for slope and the y-intercept. Wait.
You are absolutely correct. What about Jerry?
Isn't the first one like a linear equation?
Yes, it is, absolutely. These two equations are ways that, these two formulas actually, or generic formulas, are ways that you can determine the equation of a line. Now, as you can tell, that's probably pretty useful. If you have any line, for example, the first one is called, this first one right here. Let me get my pen out so I can actually draw on the screen. Tell me if you can see it. I'm on highlighter mode. So this first equation here, you guys can see me draw on the screen, right?
Yeah.
All right, so this first equation here is what we call slope-intercept form. And essentially, as you can probably tell from the things, from the denotations for these constants under it, this, if you have enough information about a line, you can write the equation of the line. So the y is the y-coordinate, any given y-coordinate, and the x is the corresponding x-coordinate. As you can clearly tell, a value of x, any value of x will return a specific value of y, and that's simply how a line works. A line, or as Jerry said, a linear equation, has a specific y value for every single x value. Does everyone understand that? All right, please let me know if I'm going too fast, because I feel like that kind of happens kind of often, especially in this short-term class. So what this first equation does is called slope-intercept form. Is the m is the slope of the line, and the b is the y-intercept. So for any given line, as long as you know the slope, which is m, and the y-intercept, which is b, you'll be able to find any x value, or any y value from any x value, or any x value from any y value. So, for example, let's say that we have a graph, and the graph simply looks like this. The graph is a simple line like this, and I'm just going to put some dots in here so that everyone has a general idea of how this graph would look. So it simply looks like this. Does everyone understand what slope is? Everyone understand what slope is? Slope is simply rise over run. And what that means is, for any given point on the line, for example, let's take this point here. The rise, which is the distance off the x-axis, which is clearly 1 here, and over, this is a rise, over the run, which is the distance from the y-axis, which is this value here. So we have this value, so you can think of it like up and towards the right. So as you can see here, the slope here is, we have 1 as a value for the rise and 1 for the value of the run. So the slope here is 1, which is also equal to the m, the constant here, which is the constant here in slope-intercept form. So that's simply slope. And then the b value here is the y-intercept, which is simply the value of the value on the y-axis when this line intersects it. So this, everyone knows, I hope everyone knows that this is the y-axis. And then this line, when it crosses the y-axis, which just happens to be at the origin, is 0. So our b value here is 0. Does everyone understand that? How to find the slope and the y-intercept? Everyone understand that? All right, perfect. So now everyone knows how to write in slope-intercept form. It's simply, once you have, let's say we find a line and it's like y equals 3x plus 6. As you can clearly see here, if we had like one value of x and we wanted to know what was the y for it, we could just plug in that for x and then find the y, or we could do the same with y. We had a y value and you wanted to find x. You can plug in the y value and just simply solve for x. So I'm now going to ask some questions. For this equation here specifically, can anyone tell me what is the m value? What is the slope of this line represented by this equation? I've called on Jerry quite a few times. I'm going to wait for someone else. Anyone else? Brian is at a hand? All right, Brian.
All right. I think the slope is 1.
Okay, why would you think the slope is 1?
Wait a second. Oh, because the line travels at like wait.
Sorry. Let me make something clear. This line here is not represented by this equation. This equation is just something I came up with.
Oh, sorry.
Yeah. So I'm just going to erase this. Hope everyone understands the general concept of slope. I'm going to ask for this equation specifically. What is the slope of the line?
3.
3? Fantastic. As you can clearly see, if the equation is written in slope-intercept form, it will match up precisely with the y equals mx plus b. And so 3 is our m value, which is slope. And guess what our b value is? Shocker, it's 6. Because they line up. B is the y-intercept. So if 6 is the y-intercept of this line, what we know is when that line passes through the y-intercept, the y-axis, the horizontal axis, the value of that y-axis will be 6. So let's try and plot this line here. We can just generalize it. So we know that the slope is 3. Now, what does the slope of 3 tell us? The slope of 3 means that the rise over run ratio is 3. So for what this means is for every 1 unit that we move to the right or the run, we move 3 units up. Does that make sense to everyone? Rise, this is rise, and this is run. And our equation for slope, this m value here, we can find it if we know the line. We know if you have two different points on line. Let's say we have 2 different points on line. And as long as you know the ratio of the rise between the 2 points and the run of the 2 points, you'll be able to find the slope. So a slope of 3, what that tells us is for every 1 unit that we move to the right, which is a run, we move 3 units up. It's rise over run. So 3 over 1 obviously gives us a slope of 1. So what would a slope of 3 look like? A slope of 3 would look something like this. So for every 1 unit that we move to the right, which is run, we move 3 units up. So it looks something like this. And the slope is constant throughout the entire line. So that's assuming the point starts at the origin. This is what a slope of 3 looks like. Just imagine that that does go through that point here. So the rise is 3 and the run is 1. So rise over run, that gives us a slope of 3. And so for this equation specifically, the y equals 3x plus 6. What we know is that the slope is 3, obviously, and we also know that the y-intercept is 6. Now, how do we put this into an actual line? We know that when this line crosses the y-axis, which is this right here, the value will be 6. So we can simply plot that out. 1, 2, 3, 4, 5, 6. So it intersects this point. That's the y-intercept. And the slope is 3, which means from this point, if you go 1 over and you go 3 up, there's another point there. That's what slopes tells us. And this is what the line looks like. This is the equation of this line here. This second equation is a bit rare, but it is called point slope form. And it might be a bit easier to understand because it gives more direct values. And essentially what this tells us, what this equation tells us is y is for if you have 2 points. If you have 2 points that you know are on a line, you can write the equation. of the line from them using this equation here. So we have the y-coordinate of the first point and the second point, and then the y-coordinate of the x-coordinate of the first point and the second point. So let's say I had 2 points. Let's say I have 3, 5, and 8, 10. So what would this tell us? And let's say I want to find the line, the equation of the line from these 2 points, assuming that these 2 points are on a line. What we can do is we can just plug in the values and it'll give us the equation for the line. So it says y is the y-coordinate of the second point. So this is our first point here, and this is our second point here. So the y-coordinate of the second point, which is 10 here, minus the y-coordinate of point 1, which is 5, equals m. Don't try to solve for m just yet. Finish putting in what you know. Equals the slope m times the x-coordinate of point 2, which is 8, minus the x-coordinate of point 1, which is 3. And now you can simply simplify this equation. You get 5 equals m times 5, shocker. And what do we get? Now we can treat m as a variable because we're solving for it. 5 equals m times 5. What's the answer? M is obviously 1. So now we've solved for slope, m equals 1. And then for this line, you know that for this line, the slope is 1. For this equation, however, the point slope form, the point slope form, it does not directly tell you the x-intercept or the y-intercept, but you can find them because once you plug these in, when you try to solve for the x-intercept happens when the y value of a coordinate is 0. So examples would be like 1, 0, 2, 0, things like this. These coordinates, if they appear on a line, these are x-intercepts. And y-intercepts are simply when the x value is 0, so like 0, 3, 0, 4 would be y-intercepts. And so you can simply, you can plug in the value of m is 1. And then if you want to try and find the y-intercept or the x-intercept, you can plug in 0 for their corresponding values. We're going to move on to something a bit more complicated in which we will actually use this in a real life scenario, and that is in statistics with line of best fit. This is probably the most common way you will see this being used. And let me grab an example. Let me see if I can screen grab this. All right, so we have an example here where the exercise would like us to identify the line of best fit. I'm going to copy paste it into here. All right, so this is probably the most common thing you'll see being used is how would we find the line of best fit for a scatter plot? Now, everyone knows how scatter plots are made, right? Everyone knows how to do data taking, like for example, for this specific one, we have diameter and height. Like for example, you might be diameter of, I don't know, Pringles cans. Like how does diameter relate to height? And let's just say we have 1 million Pringle cans and however many is here. And for each diameter, there's like a general height. And as you can clearly see, there's a positive trend here. As the diameter increases, the height also increases. Now, how do we find the line of best fit? Does anyone know what the line of best fit is? No one knows what the line of best fit is? The line of best fit is if you have a scatter plot like this that shows a somewhat generalized linear, it looks like you can put a line through the center, like the majority of the center of the points like this. You can use this line, this approximate line, to create a general line of best fit. And what that means is that line will show the average or approximate relationship between diameter and height. For example, if we didn't have a line of best fit, it'd be really hard to describe how diameter directly relates to height. You can say like, oh, maybe for this specific point we had whatever diameter for whatever height. Oh, but for this point we had whatever, and we're not going to go through all the Pringles cans, right? We're going to try and use this line that we've drawn here to give an approximation of how high a Pringles can will be in relation to its diameter. Now, the line of best fit is never perfect. It only gives an approximate relationship between these values, such as diameter and height. But in most cases, it's good enough, especially if this scatter plot shows that you can kind of eyeball how there's a line of best fit. Line of best fit does not work. Be sure to recognize that line of best fit does not work for any just random scatter plots. There has to be, you should be able to eyeball that there is a general linear relationship. Like you can draw, the points are kind of in a line. If they're in like a curve or they're random all over the place, those, you can't use a line of best fit anymore. If it's a curve, it's exponential, or yeah, it's normally exponential if there's a curve, and if it's random all over the place, like you can't find any line, you can't draw anything through it, that there you can normally say there's no correlation. For example, like if there were dots all over the place on this scatter plot, you could say, well, this data isn't really worth very much, and we can't really draw a line of best fit because the diameter doesn't have anything to do with the height because it seems so random. But for this one that we're given here, we can just eyeball a line of best fit. And there are ways to mathematically calculate the perfect line of best fit that is the best mathematical approximation of all these dots. But for our general purposes today, we will just be eyeballing it. So I think this line, if I draw it like this, I think this is a pretty good approximation of the points. Does everyone agree? I think this line here is a pretty good approximation of all the points here. So we ask ourselves, well, and we're going to be using point slope for most of these. So we're going to be using this y equals mx plus b. How can we write the equation of this line from y equals mx plus b? Now for y, what we want to do when we define a line like this, we're not too worried about solving for y or x, so we'll just leave them as b. We're concerned about solving for m and solving for b. So we can simply put the formula here, y equals mx plus b. M is the slope, and b is the y-intercept. So what can we see from this graph here? How do we find a slope? Well, we can take 2 points. We can take any 2 points on this line that we have here, and then we can find a slope from them. And generally, you want to pick points that are pretty close to whole numbers or nice, easy numbers to work with. For example, I don't want to pick like a point here and a point here, even though it still works. I can still calculate slope from these two. They're kind of in the middle, and I would have to eyeball it. So instead of picking those 2 points, oops, I accidentally erased my line. Goodness. Instead of picking those 2 points, I might pick something that's easier to eyeball, like, let's just assume this point here is right at the intersection of these 2 grid lines, and let's pick like a point here, which seems to be halfway between these 2 grid lines and right on the 2.4 height. So you want to choose 2 points that are easier to work with. And you ask yourself, well, how do we find slope? It's the same thing, rise over run. You want to draw a triangle like this, and the height of the triangle is the rise, the bottom of the triangle is the run. So let's see here, our rise value here, it seems to go from 2.4 to 4. So how much would that be? So what would be our rise, Marco?
1.6.
Fantastic. Our rise is 1.6. Oh, I see Grace has joined. Grace, well, nice to meet you. I'd like to introduce Grace to everyone. She's a new student here. I don't think she was here last time. Grace, I will ask you to be on camera for the duration of this lesson, if you can. All right, fantastic. Welcome to the 7th grade math tutoring, Grace. So, Grace, how about you answer this question? What approximately, assuming, assuming that this bottom, this value here is 2, what approximately would be the run of this slope?
The what? Of
The
that?
run of the slope.
I joined late, so what exactly does run mean?
Yeah. So, do you know what slope is?
No.
You don't know what slope is? Okay, I'll briefly explain it again. So when we have a line, when we have any line like this, it represents a linear relationship. And what slope just tells us is kind of how steep or how shallow that line is. And we can calculate slope by taking rise over run. Now what rise is, in between 2 points that you know are on the line, the rise is a difference in the x value, or how high, or how much upwards. What's the upwards difference between these two lines? For example, this line at these 2 points, the rise would be 1.6 because it went from 2.4 to 4. So the upper x value, which is rise, is 1.6, and run is simply the base of the triangle. How much did you move along the y-axis? And now, assuming that this midpoint here is between 2 and 4, we're just going to assume that this is 3, and we went from 3 to 6 for our base value of the triangle. So 3 to 6, our run would be 3. So this is our slope for this line. 1.6 divided by 3 is pretty tricky. I don't really want to do it. I need to grab a calculator, but we can approximate. Don't actually do this if you're doing a test. I'm just doing this for simplicity's sake. I'm just gonna make this 1.5. So 1.5 over 3. This is simply a slope of 1/2. A slope can be slope can be fractions as well. A slope of 1 simply means that for every x value, for every additional x, you move up. Every single step you take upwards, you'll also take 1 step to the right. So it's a perfectly diagonal line across. And so for this equation here, we have rise over run equals 1/2, which means for every 1 step that we move upwards, we will move 2 steps to the right. So that's why this line looks kind of flat. If it was a perfectly 1-to-1, it would look something like that. It looks steeper because it's 1-to-1. All right, so that's a brief slope thing. And so we found our m value. Our m value for slope is 1/2. So we can simply plug that into our equation. Y equals 1/2 x plus b. And we still need to find b. How we can find b is, if you were given this graph, you can simply just look for it. You can see, oh, where does this line pass through? Where does this line pass through this y-axis here? And you can simply look for it. And so far, it looks like this line passes through this line passes through the, oh, wait a minute. I just realized that the example I use is not very good. But let's just assume that this point here is 0, 0. Let's just assume it's the origin. And so when this line passes through the origin, the origin is obviously the intersection of the y-axis and the x-axis. So to give you an idea, let's say our line is like this. It passes through the y-axis here at a value of 0. So the point here that it passes through is 0, 0. You look for the y value here, and it's 0. So our equation of this line would simply be y equals 1/2 x. Since b is 0, we don't need to write it in. So this would be the approximate eyeballed line of best fit for this equation. And I'm going to give another example, and I know it's a little bit confusing. We're going to spend quite a little bit of time on this. But I have another scatter plot that I want everyone to do for practice. I'm just going to screenshot here. I'm going to move this down, way down. Okay, Now, this scatter plot might look a little menacing, and you might say, oh, how do we deal with that? That slope doesn't look like any line that we can, it doesn't look like a line that we can draw through it. Well, we can still draw a line. This line approximately looks something like this, right? The slope of a line can be negative. Why? So far, the rule of slope still applies. This still rise over run. But let's say we have a point here and a point here, and our triangle is drawn like this. Well, you say, oh no, we go downwards as we move from point 1 to point 2. By the way, if the line looks like this, you always progress from left to right. So we always progress in this direction. As an example for this one, for this line, we progress from left to right. Here's our point 1 here, and here's our point 2 here. So we have points 1 and 2 here. And you say, well, the difference between point 1 and 2, we went downwards. How do we do that? How do we insert that for rise? It's simply negative. For example, let's say the distance that we moved down was like we moved down like 10. And then for rise, instead of putting positive 10, you would simply put negative 10. We move downwards instead of moving upwards. And for this, for run though, however, as we can see from this line here, we're not going backwards. From number lines, as I hope everyone's familiar with number lines, as you move to the right, it becomes more and more positive, right? If you move to the left, it's a negative value. So this value, we're still moving from left to right. So this value here, let's say it's like 6 or something. It will be a positive 6. So what we have here for our slope, approximate slope, these are random numbers. This isn't the actual slope. I'm just putting in random numbers. It would be minus 10 over 6, and that would be 5 over 3. So that'd be our slope, minus 5 over 3. Now I'm going to ask everyone to try and write out the approximate line of best fit. Here's the equation here, y equals mx plus b. M is a slope, rise over run, and b is simply the y-intercept. The y-intercept is what the y value is when this line touches the y-axis. This is the y-axis. This is the y-axis. This is the x-axis. So the b is the y-intercept is when this line, when your approximate line of best fit crosses the y-axis, the value of the y. That's just your y-intercept. So I'm going to ask everyone to try and come up with an approximate line of best fit. If you don't understand something, please let me know. I will gladly explain it to you. I'll draw a line for everyone. Does everyone agree that this is a fairly good representation? This line here? Wow, that was pretty straight, I think. Does everyone agree that this line is a pretty good eyeballed line of best fit? So can everyone write out the equation of this line in particular, our approximate line of best fit? Please post your answers to me directly in the chat. Also, I must say today's lesson, I accidentally put in free math tutoring 4 for the document on the website. It's not free math tutoring 4, obviously. You got some genius 4th graders maybe, but it's the correct file. It's a correct file. I'll also be uploading these notes, so it's not a problem. Please direct message your answers to me, and I will receive them. If you don't understand, don't be afraid to tell me you don't know or you don't understand something. Don't be afraid to get wrong, but I will encourage everyone to at least try. I'm going to give everyone until 7:40. Wow, time is passing quick today. Once I've received a majority of the answers, I will be walking through this problem, and I want everyone to pay attention to what I do. All right, someone's asked me a question. They asked, well, clearly for this problem up here, you've used 2 points, and we can find the rise and run from them. And they ask, well, how do you get the 2 points? Now, the 2 points can be any 2 points on the line. There's no restriction to what you can and cannot choose. But as I said before, you would most likely want to choose easy points. Like, for example, let's say on this line, let's say we can approximate, it looks like this is an easy point to work with. It looks like it's in the intersection of these two. So we can approximate this point here, let's say is about like 5, 100. And let's pick another easy point. Let's say this point here, it's about at the intersection of these 2 markers. It's not like grid lines. So we'll say though it's probably like 1596. So that's how you find your 2 points. You just pick easy points that happen to, cross these grid lines across the graph. And I've made it a little bit messy, so I will highlight the original line. So as you can clearly see, this point right here is pretty close to one of the grid line intersections. This point right here is also pretty close to one of the grid line intersections. Just choose easy points to work with. You don't really want to choose like points that are in the middle. Like for example, I wouldn't want to choose this point right in the middle here because there's no grid lines and I kind of have to eyeball it. So these 2 points here are easy to work with. Those are the points that I would use. So I've given everyone 2 points to work with. 5, 100 and 1596. If anyone else has any questions, just let me know. I've received 1 answer so far. I've received 2 answers so far. In about 2 minutes, we'll just be walking through the problem. It's 7:38 right now, and you have about a minute and a half. I have quite a few questions, so I am just going to wait until the walkthrough. I think I do actually have everyone's answers. I'm just going to briefly go through it. All right, yep. Actually, I'm missing just 1. So, I think actually I'm just going to start the walkthrough now. Oh, Alina's still working. Take your time, Alina. All right, we've got around 1 minute left. Don't be afraid if you can't finish on time. We are here to just learn. We've got about 10 seconds. All right, fantastic. I'll just start walking through it. And I'm going to erase some of these values just so that it is easier to look at so we can. So let's say if you were given this problem, I'll show you directly how to work through it if you were just given it on like a test or something. I'm going to keep this here though. So the formula of the line of best fit we can use is y equals mx plus b. The y and the x, you leave them here. You're not trying to solve for m, y, or x because all you need to do is find the slope and the y-intercept because those describe the line. So we're not trying to solve for any of these values from this equation. No. We are simply finding the value for M and the value for B from our line of best fit. And what we can do here is, the first thing you need to do when you're doing a line of best fit is draw your approximate eyeball line of best fit. So I would say it looks something like this. So that looks approximately like the line of best fit. And then step 2 is to find 2 points that are somewhat easy to work with. And as I said before, the point here, point on the line right here, looks just about to be 5, 100. So nice, easy point to work with. It's also nice numbers. It's just like a point that you can eyeball from looking at these markers on the side here. And another point, like I said, is like, maybe this one looks pretty good. Something like 1596. 1596. So we've chosen our 2 points here. Does everyone agree with 2 points? Everyone knows how to find the 2 points from their line of best fit. Does everyone understand that? Everyone understand that? I want a more confirmative answer. Everyone unmute and say yes if you understand.
Yeah.
Yes.
All right, fantastic. Brian and Grace, did you say yes? Yeah, Brian, go ahead.
Yes.
Yep, Brian says yes. Grace, what about you?
Yes.
All right, so everyone knows how to find these 2 points, right? So what we can do now is we simply find the slope. This M value here, it means the slope. I don't know if Grace saw this because she joined a little bit late, but I will be moving up here so she can look at the equation here. It's an equation of line and slope intercept form. The y is a y coordinate, the m, which is the value here, is the slope, what we're calculating right now. X is the x coordinate, and b is the y intercept. So what happens here is we try and solve for m for this line. Each and every single line has a different slope and a different y intercept. So the slope here, as before, is rise over run. So our triangle that we can draw in between these 2 points, our rise, it drops from 100 down to 96. So this rise is -4. And the run, as we move from 5 to 15, or as we move from 5 to 15, we move forward 10. So our rise over run is simply 4 over 10. And we can simplify that to -2 over 5, or minus 0.4 as our slope. And so once that happens, we've gotten our value. Our value is simply 2 over 5. Our n value, our slope value is 2 over 5. So what we can do after that is we can simply put that into our equation. We know the value for n. So it's -2 over 5. Does everyone understand that part? You can solve for the m separately, and then you just put it in the equation where it's supposed to be. So this used to be our m in the equation. M equals slope. So we found the slope by drawing the rise over run. We put it in the equation. Now we need to find the y-intercept. The y-intercept is very easy to find. As you can clearly see, our y-axis is right here. The line intersects the y-axis like around here. And what's the value on here? It looks around to be like 103, 104, right? So this coordinate here, when it intercepts the y-axis, in the y-intercept, the x value of the coordinate is always 0. Because on the y-axis, this axis here, it's all zeros. We haven't moved forward or backwards. It's at 0. We haven't moved that way or this way. So the value for the x coordinate is always 0. And so our y coordinate at the y-intercept seems to be around 103, 104. If anyone wrote either 103 or 104, they'd be right. So b is simply our y-intercept value, and b, as we can clearly see from here, is like 103. So the equation of the line is equal to y equals -2 over 5x plus b. And b value is like 103, 104. If you roll 103, 104, it's okay because we're just eyeballing it. So this would be the equation of the line of best fit for this specific graph. Does everyone understand how to find it? Alina and Grace, are your questions answered? Speak up. Speak up. Anyone have any questions? Please do not be afraid to answer, because nothing good comes from keeping silent.
I get it.
All right, Alina, you get it. Fantastic. Grace, what about you? Why does -4 equal 2? Oh, yes. Our rise over run fraction, as you pointed out, is -4 over 10. And what we ended up doing is we simplified the fraction from -4 over 10. We simplified it into -2 over 5. These two fractions are exactly the same. We simply just simplified it. Does that make sense? If you wrote the equation like y equals -4 out of 10, x plus 103 or 104, this is also correct because they're the same number. But most schools and most tests that you take, you probably will have to simplify the fractions into their simplest form. So we just went ahead and did that and turned our -4 over 10 into -2 over 5. It's the same value. Does that make sense? All right, fantastic. So does everyone understand this? Everyone understands how to find line of best fit? It's really just, how do you write an equation of a line? And we just do it, we just put it into statistics. We're gonna move on. I am actually going to skip the Venn diagram section because I don't think it's used super often. I'm going to move to the averages section. I'm gonna copy paste the question that I have here. And I hope most everyone knows what an average is. All right, so I'm gonna ask everyone, does anyone know what average is? What the mean is? It's often called the mean. It's spelled the same way as the emotion mean or actions mean actions, but it means in something mathematical. All right, we have Marco. Marco, what is the average? What's the mean?
The average is kind of like you take all the numbers and the thing. So if you have 5 numbers, you take the 5 numbers, add them together, and then divide them by the number of numbers you have.
Yes, perfect. Now, Marco did give an excellent explanation of how to find the mean and what it is mathematically, but can someone tell me what the average is used for? Why do we find the average? How is it useful? Yes, Jerry?
I don't really know why it's useful, but it kind of helps you find like the middle number.
Perfect. I'm just gonna build off what Jerry said, and just like the line of best fit, what the average does is when you have a lot of data in numbers, like for example, you took a survey at your school, it's just like, how many cupcakes can you eat at one time? And you asked everyone that. And then people gave all sorts of answers. People go from like half a cupcake to like 30 cupcakes at a time. And so your data isn't very useful if you have all these small numbers by individual people. And it's useful because you can attribute these singular values to specific people. But let's say you're coming up, like you have like a birthday party that you're hosting at your school, and you say, well, I'm not gonna like tally up and like count how much each person can eat and put those exact values in. I'm just gonna say, in general, approximately how much can the average person eat? So like on average, like within your school, how many cupcakes can like a normal person eat? Like in general, does everyone understand what I mean by that? Like in general, how much should someone eat? We obviously shouldn't give outliers. Like we shouldn't give 30 cupcakes to each person. We shouldn't give half a cupcake to each person. We want a general number that's comfortable for the majority of people. And that's simply what the average does. It gives us a general idea of the most common number, or the number to best represent a data set. And this happens most of the time. The average gives the best number to represent all those numbers. The one number to represent all those numbers. As Jerry said, it's kind of a middle number, but it's not necessarily the middle number. It's just the best number that we find mathematically to represent the whole data set. And now the average is not always the best number, but I'm just saying it is most of the time. Most of the time for like I said, for the cupcakes, you will use average to find, for example, like, let's say we have all range numbers from like half cupcake, 2 cupcakes, 3 cupcakes, 5 cupcakes, all the way up to like 30 cupcakes. And your birthday party, and you figure out, like Marco said, you add up all the numbers and you divide by the number of numbers. And you find out that like, oh, on average, each person can eat like 3 cupcakes. So if you have like 50 people attending, you're just going to multiply 50 by 3. And then you have, to bring around 150 cupcakes. So that's simply what the average is. It's not always correct, but for our general purposes today, it's not always the best representation, but for our general purposes today, it is the best representation. And so I'm going to ask everyone, I hope everyone knows at least how to do average. I'm going to ask everyone, what's the average of this data set here? It's the average of our number 1 data set here, 2, 5, 4, 3, and 6. What's the average of this data set? Simply give your answers to me. Okay, seems like everyone is pretty good at finding averages. The average of this data set is, let me do this very quickly in my head. The average of this data set is 4. Yep, so congrats to everyone getting this right. Yeah, yep, everyone got it right. So it's not always so simple and easy, but the general way to find average is you simply add all the numbers together and then divide by the sum of the number of data values. So this would simply be 5 plus 4, 2 plus 5 plus 4 plus 3 plus 6, which is equal to 20, divided by the number of numbers, which is 5. 20 divided by 5 is 4. And then no matter what numbers you get, even if they're decimals, even if they're fractions, even if they're difficult to work with numbers, as long as you add them together and you divide by the number of numbers, it will return an average to you. Now, an interesting thing that you will be actually using average for is, how can we manipulate the average of a data set? Let's say your grade in school is based off the average test score that you've taken. For example, let's say in math, your grade in math is solely determined by your test scores in math. And let's say you have a test score of like 95 or something. And you go home and your parents get mad at you. They're like, why is it not 100? I'm kidding. You go home and your parents ask you, can you raise it to a 98? Can you raise it exactly to a 98? Because that would make us happy. I know my parents would be happy. So, but you say, well, how do I calculate what score I need to get on the next test or the next couple of tests? How do I calculate what score I need to get to raise my grade, that exact percentage? So if for any data set, it's like, for any data set where we want to change the average, you ask, what should we add to the data set to move the average to what we want? For example, number 3 is, you can also take away numbers to manipulate the data set, but we're just going to assume that it's like chronological. You can't go back in time and do better on the task. We're just going to assume that you can only add numbers to the data set. So number 3 is, how can we change the average of the previous set to 38? What number do we have to add? So far, what is the average of this data set right now? We have 10, 16, 25, 32, 45, and 50. 50. I'm going to quickly do this with a calculator. So we have 10 plus 16 plus 25 plus 32 plus 45. Oops, I did wrong. 10 plus 16 plus 25 plus 32 plus 45 plus 50. It gives us 178. and divided by 6 numbers here is 29.6 repeating. And you might ask, well, wow, we have to change it to 38. How can we do that? And what we need to do is we add one number. When we add one number, let's say x is the number of numbers increases by 1, and your value increases by whatever amount. So let's say we add one number. How many numbers do we have now? We have 1, 2, 3, 4, 5, 6, 7. We have 7 numbers. So instead of by the number of numbers, we'll have by 7. So we simply need to find something divided by 7, which is a number of numbers, gets us to our 38 that we want. So we can simply denote this question mark. We can turn it into another x, or since we have already used x, we can turn it into y. Oh wait, no, it is what? It is x. So our mystery number here that we have to add is, we can put it into our unknown value. You can simply put it as x divided by 7 equals 38. And then we can solve for this x. Oh, what am I saying? Wait, oopsie. It's all the numbers. It's all the numbers added together plus x. So we have 10 plus 16 plus 25 plus 32 plus 45 plus 50 plus our extra number here, x, divided by 7 equals 38. So in total up here we have 10 plus 16 plus 25 plus 32 plus 45 plus 50. We have 178 plus our mystery number x divided by 7 equals 38. And then this is simply a, this is just a one variable equation. 778 in parentheses plus x divided by 7. So we multiply 7 times 38. We multiply by 7 on both sides. So we get 178 plus x equals 266. And 266 minus 178 on both sides will give us an answer of 88. We need to add 88 to that data set to move the average up to 38. Does everyone understand? All right. So when you try to manipulate the average by adding values, what you do is you have to remember that you can do this multiple ways. Let's just assuming we're manipulating the average by only adding one extra value. So it would be total sum over the number of numbers. So number of numbers. And so our number of numbers goes up by 1. So it becomes plus 1. And the total sum gets added by x, which is our mystery number. Because it's the number that we're adding, the total sum is now the previous total sum plus the x. So equals the average that you want to raise it to. Equals y. We can denote y as the average. So if we know the average, let's say like we want to move it to like a random number like 60, we simply increase the number of numbers by 1, and we increase the total sum by x, and then we solve for x. Simple. We can find x by solving for x in this equation. Does everyone understand? If you have any questions, please feel free to stay after. I would recommend Grace, you stay after because you came a little bit late today. I'd be willing to go through things that you missed with you. All right, so that is just about class for today. These are the line of best fit and mean are probably the most useful statistics principles, some of the most basic and useful statistics principles that you'll have going into 7th grade, going into 8th grade. So I hope everyone understands how this works. Point slope form is also used, but it's not used as commonly. So I would say for your purposes, as long as you remember this y equals mx plus b, you should be good. So yeah, that's just about it. I hope everyone understood. If you have any questions, please feel free to stay behind. And yeah, class dismissed. I hope everyone has a wonderful weekend. Bye, everyone.
Bye.
All right, so Grace, I will be going over some of these concepts with you. Grace, do you understand what slope is now? So you understand the rise of a run. Perfect. Do you understand this equation up here, y equals mx plus b? All right, see ya, Priyanka. Thanks for dropping by.
Yeah, bye-bye. See you next week.
See you.
Bye.
Grace, you can just unmute and talk to me directly now.
Okay, I was actually pretty scared of unmuting at first because a new class, I'm not really used to that.
Oh, I apologize. I know you were supposed to attend the first class, but your mom, I owe you an explanation actually. Your mother had signed up with the wrong email. Well, not a wrong email, she had just made a typo. So I was unable to send the reminder for the first class with the information and everything to her. So that's kind of also my fault. I hope you've acclimated yourself to the class pretty fast. The notes for lesson 1 are on the website. You know how to reach that, right? Like the class syllabus and stuff on the website. All right, perfect. So if you have any questions, please go look through the first couple notes. So do you understand? And I hope this class isn't like too brutally new or anything. I hope it's not too far outside of what you know, right? So do you understand what this equation means? The y equals mx plus b. All right, so I'll explain it to you. So what y equals mx plus b is, this is simply the equation for a line. And we can describe any line with this equation. So as you might know, a line has like an infinite number of coordinates on it, right? Just coordinate points that are along that line, right? And those coordinate points have an x value, and a y value, right? Right. So what this equation does, when you solve for the m value and the b value, let's say we've solved for y equals 8x plus 7, when it describes a line for any coordinate point, if you know the x, it will give you the y that is corresponding on that line. That's why it's so useful. And so you know what the slope is, right? And you also know what the y-intercept is, right? Do you know what the y-intercept is? So if you have a line and you can find the slope and you can find the y-intercept, you come back to this equation where the y equals mx plus b, and you just plug them in. You just put in the values. There's no solving, no nothing. Let's solve our slope was like 4 over 3, and our y-intercept was like 2.5. We simply plug it in. It's just y equals 4 over 3, which is a slope, remember. As you can see here, m is equal to slope, x multiplied by x plus our y-intercept is 2.5. There's the equation of your line. Does that make sense now? The y equals mx plus b. Yeah, and so our goal is to do this with any given line, and especially lines of best fit. So I'm not actually going to worry too much about the point slope one because it's not used as common. You'll learn eventually. So for line of best fit, do you know how to draw a line of best fit? No? So a line of best fit is, a lot of times when you get a scatter plot, do you know what a scatter plot is? Right, so a scatter plot, it just looks like this. It's just a graph that has a bunch of dots on it. That's what a scatter plot is. So sometimes you might notice that a scatter plot, it kind of looks like the points have like a trend, you know, they're kind of like they follow a line, kind of. So for any scatter plot that looks like, you should be able to eyeball it, as long as the points look like they kind of follow a straight line, you can write a line of best fit for it. If the points are like in a curve, if the points are like, if they're like bounce off the axis or something, or if they're just all over the place and you can't like draw a line through them, then you can't write a line of best fit. But for example, for like this first equation here, obviously, it looks like the points, you know, it looks like you can draw a line through. So do your best and draw a line that goes through like the center of the group of points. That's your line of best fit. For your purposes, what grade are you in, if you don't mind me asking? You're in 3rd grade going into 4th? Why are you attending the 7th grade one? Well, I mean, I guess it's not really a problem. It's not really a problem for people to be jumping ahead in these tutoring classes, but these tutoring, I must tell you that these tutoring classes are the ones that we're providing at Megrez, the free tutoring ones, are usually meant for kids to catch up in or, to review over the summer. They're not really meant to boost you forward into 7th grade. But I guess I can imagine. I can imagine that your mom probably signed you, your parents probably signed you up. But as long as there's like not a huge gap in knowledge like between what I'm teaching and what you know, it should be all right. So you know how to draw a line of best fit, right? Just eyeball it, just draw a line through most of the points, right? So there you go. There's your line. And now you can simply find the slope and the y-intercept from the line that you've drawn. And then you can plug them into this equation. There's your line of best fit. Does that make sense? So I'm actually going to give you an extra question here. If I have a graph that looks like this, say we have like 1, 2, 3, 4, 5, 6. If I have a bunch of scatter points that look like this, if I have a scatter plot that looks like this, could you tell me the line of best fit for this? Also, could you unmute and like talk through your process out loud? I think it helps.
How exactly do I tell you a line for the best fit?
Oh, right. Can you annotate on the screen?
Viewer and annotate.
Yeah, simply
Yes?
just perfect. Just draw the line of best fit for this graph.
I'm terrible at drawing.
It's fine. Do your best. Don't worry. I'm not super good at drawing straight lines either.
My best line I could do.
Perfect. Perfect. That's pretty good. That's pretty good. So, can you write the equation for this line of best fit? I'm going to put the formula back up here so you have equals x plus b.
Wait a second. Can I just draw on the screen?
Yeah, go ahead. Go ahead.
I'm gonna use the opposite color so I don't get.
Perfect.
These are not perfect dots.
It's fine. You can just try and draw straight lines. Doesn't matter. All right. So those are your 2 points, right?
2 points.
So, right. That's the next step. Yeah, that's the correct step. Now, how will we find a slope from those 2 points?
A slope.
Yeah, we need to find the slope between those 2 points.
Try to draw.
Perfect. To make it easier on you, I'm just, oopsie, I did not mean to do that. We're just gonna assume that the marker that you've drawn here is 2, just to make it easier on you.
I tried to line them up like before here and not to. Okay, so shaky numbers for these lines.
Right, so -2 is the rise. Yep, that's correct.
It's kind of weird how these two are basically the same numbers except for the minus thing.
Yeah, it's because I didn't draw the graph very well. In reality, if this was like a square grid, it would look like it'd just be like that. But
It would look
yeah.
different.
Yeah. Yeah. So what's the slope for this line?
Slope for this line. Basically, in the simplified form, it would just be a 1.
Yes, that's right.
So do I have to write this line or no?
No, it's fine. Just write the final value.
Okay, the non-simplified form.
Yep, perfect. So what's the slope? So what's the final simplified value of the slope? Is it a, are you sure?
I'm kind of sure, kind of not sure.
What's -2 divided by 2?
Wait a second.
You've done this part correctly. It's your simplifying that you've made a mistake in. -2 divided by 2, what value is that?
-2 divided by 2. -1.
Yep, you're right. So the slope, our n value is simply -1. We can plug that into the equation. Y equals -1x plus b. And because it's -1, we can just simply write y equals minus x. Does that make sense? Y equals minus x plus b.
Yeah, that actually does make sense.
Yeah, -1x is the same thing as minus x. And then plus b. So what's our b value?
The y interception point?
Yes, perfect. So what's the value there?
6.
Yep, you're absolutely right. So what's the final equation of this line? You can just say it to me. You don't have to take
Y equals minus x plus 6.
Precisely. Y equals minus x. I'm going to write it out. Y equals minus x plus 6. That is perfect. There you go. That's your line of best fit. Does that make sense now?
Yes.
All right, perfect. Do you have any other questions? I'm going to erase your...
I
Okay,
just
perfect.
clicked clear.
All right, perfect. So do you have any other questions or are we good?
I do not have any other questions.
All right, perfect. So you understand the y equals mx plus b. You know how to write a line of best fit now, right?
Yes.
All right, perfect. See you next class. Have a good weekend.
You too. Bye.
Bye.